So wish you all a very good evening, students. So this is the discussion of the weekly test 8 that you all had. And Saradu, ಇದು ಮಾಡ್ರಿ, stop ಮಾಡ್ರಿ. So this is the discussion of the weekly test 8 that you all had, and this is the first question of the test, question 61 serial number wise. So if A is equal to box Aij m by n is a square matrix, then which of these options is true? So square matrix is a matrix whose row number is equal to the column number, right? The number of rows is equal to the number of columns. So the number of rows is m. So that should be equal to n, right?
No, so you use that only. You use that option. Menu. Pen, sorry, pen. Here.
Yeah. Black only, but ಮತ್ತೆ ಹೇಳ್ಬೇಕಾ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಲ್ಲ
Start, sir. Start.
So wish you all a very good evening, dear students. So this is the discussion of the weekly test 8 that happened recently, and this is the first question of that test, question 61. And the question is, if A is equal to box Aij, where its box Aij m by n is a square matrix. If so, a square matrix is a matrix where the number of rows is equal to the number of columns. So which means m should be equal to n, right? So that's option 3. Okay, it's as simple as that. I hope you've understood. We'll move on to the next one. Okay, so the next question is,
Just drop it. Start now.
so this question is, which of the given values of x and y make the following pairs of matrices equal? So see, now any two matrices are equal when their corresponding elements are equal. So for this matrix to be equal, the first row first column element here should be equal to the first row first column element here. So that means 3x plus 7 must equal 0, and that gives us x equals -7 over 3. But this should also satisfy for the other values. Now if you equate 2 minus 3x to 4 here, right? So 2 minus 3x equals 4. That would give us 3x is -2, and so x is -2 by 3. So you see that you're getting two different values here and here, right? This is a different value, this is a different value. So basically no single value of x for which these two matrices will be equal. And since you need a value of both x and y, so if there's no single value of x, then there's no need to find a value of y. So basically the answer would be option 2. I hope you've understood. Let's move on to the next one. The number of all possible matrices of order 3 with each entry 0 or 1 is. So let's make a matrix of order 3. Let's say we have a matrix A, and this is of order 3. So A11, A12, or maybe we don't need to write these elements here. So let's do one thing. Let's say I just make some blanks here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically there are 9 elements that I'll have to fill because it's a matrix of order 3, right? And for each blank I have two choices, 0 or 1. So the total number of possible matrices will be same as the total number of possible choices I have, total number of ways in which I can fill these 9 blanks, right? So since for each blank I have two choices and all blanks have to be filled, so the total number of ways that these blanks can be filled is because there are two choices here. So it's 2 into 2 into 2 into 2 and go and so on, right? It goes for up to 9 elements. So it's 2 raised to 9, which is 5, 1, 2. So this is option D, right? So I hope you have understood this. We'll go on to the next one. The matrix A equals 0, 0, 5, 0, 5, 0, and 5, 0, 0 is. So there are four options given here. A scalar matrix is a diagonal matrix where all diagonal elements are equal. You can see the diagonal elements are unequal here. This is 0, then you have 5, and then you have 0. So obviously the first option is wrong. Diagonal matrix is a matrix whose non-diagonal elements must be 0. When we say non-diagonal, we mean principal diagonal, right? Non-principal diagonal elements must be 0. But you can see 5, there's a number here 5. So this is a non-zero number, right? This is a non-zero number. This is a non-zero number. So these are not on the principal diagonal. So it's not a diagonal matrix either. Unit matrix is a diagonal matrix whose diagonal elements are 1. So first of all, it's not a diagonal matrix. So if it's not a diagonal matrix, it can't be a unit matrix. Square matrix. Square matrix is a matrix whose rows and columns are equal. Number of rows is equal to the number of columns. You can see there are 3 rows here and there are 3 columns. So the answer is option D, right? It will be a square matrix. So I hope you have understood this. Let's move. If A equals 1 over pi into matrix has sine inverse pi x, x pi is the same thing, tan inverse x by pi, sin inverse x by pi, cot inverse pi x, and B is this matrix. So what is A minus B? So let's do it. Let's do A minus B. So when we do A minus B, right? Since both A and B have pi in them, so we can take this pi out and we'll be subtracting the corresponding elements. So we'll have sine inverse x pi minus of minus cos inverse x pi. So that gives us sine inverse x pi, or I can write it pi x, it's the same thing, plus cos inverse pi x, right? And tan inverse x by pi minus tan inverse x by pi is 0. So the second element 0 here. Sin inverse x by pi minus sin inverse x by pi, again 0, right? 0. And then here cot inverse pi x minus of minus tan inverse pi x. So now here we know that sine inverse of any number plus cos inverse of the same number is pi over 2, right? So this is pi on 2, and you have 0 here, 0. And cot inverse of any number plus tan inverse of the same number is also 2. This is pi over 2. And now if we multiply 1 by pi inside, we get 1 by pi into pi by 2 is half. Then 1 by pi into 0, anything into 0 is 0. 1 by pi into 0 is again 0. 1 by pi into pi by 2 is again half. Okay, we can actually see the answer from here, but if you want, I can take half common from here. So if we take half out, okay, so half divided by half is 1, 0 by half is 0, 0 by half is again 0, half by half is 1. We actually could see the answer from here itself, but still I just did this. So this is half of, and this is identity matrix, so it's half. If A and B are two matrices of order 3 by m and 3 by n respectively, and m equals n, then the order of the matrix 5A minus twice B is. So first of all, see, since m is equal to n, so I will use, let's do one thing. Let us use the letter n for both m and n, since both m and n are equal, right? So matrix A is of order 3 by m. So like I said, I will use the letter n for m also, because m and n are equal. And matrix B is also of order 3 by n. Now, see, if A is of order 3 by n, then 5A will also be of order 3 by n. So 5A is also of order 3 by n. And matrix B is of order 3 by n. Right? And if matrix B is of order 3 by n, then matrix 2B, because multiplying a scalar will not make any difference to the order. So 2B will also be of order 3 by n. So 5A minus 2B. Now, both the matrices 5A and 2B are of the same order. So the subtraction is defined. And when you subtract two matrices of the same order, the difference also has the same order. So this matrix must also have order 3 over 3 by n. The answer would be option D. So I guess we can move. If A equals alpha, beta, gamma minus alpha such that A square equals I, then this question had a little bit of use of trace in it. So we know that the characteristic equation of a matrix is x square minus trace of A, right, into A plus det A into I is O, null matrix, right? And this would be satisfied. This is the characteristic equation of a matrix of order 2. So it has to be satisfied by this matrix. So we need det A. So I'll find det A quickly. Det A is alpha into minus alpha is minus alpha square minus beta gamma. And trace of A is nothing but the sum of the diagonal elements, principal diagonal elements, alpha minus alpha. This would be 0. And matrix A would satisfy this equation. So we have A square minus trace of A into A plus det AI, because every matrix satisfies its characteristic equation. So matrix A has to satisfy this equation, and trace A is 0 like we have found. So A square, this term becomes 0 because trace A is 0. So this would be 0. And det A we have found is minus alpha square minus beta gamma into I. So it is minus, or I can write it this way, plus of minus alpha square minus beta gamma I. This is O. And now they have mentioned here that A square is I. This may not strike. You have to substitute A square as I here. So if you substitute A square as I can do one thing. I can be written as 1I. So I'm writing I as 1I. This is 1I plus, and we have minus alpha square minus beta gamma into I is O. If I take I common, the identity matrix common from this expression, I get 1 minus alpha square minus beta gamma, right, into I is O. Now we know what the identity matrix is. It is 1 0 0 1. If we multiply this with the identity matrix, we will get this 1 minus alpha square minus beta gamma 0 0 1 minus alpha square minus beta gamma. This is a null matrix. So in a null matrix, every element is 0. This is the equation that would form. So from here we can get the value of 1 minus alpha square minus beta gamma. So from here, when we equate the corresponding elements, we get 1 minus alpha square minus beta gamma is 0. 1 minus alpha square minus beta gamma is 0. So it's option 3. Okay. So I hope it's clear. Construct a matrix Aij of order 2 whose elements are given by Aij is e raised to 2ix sine jx. Okay, so I is the row number and j is the column number. So let's make that matrix. Let's say it is matrix A. Now for the first element, I will be 1 and j will also be 1. So you'll have e raised to 2 into 1x, that is e raised to twice x sine into sine 1x, that is sine x. For the this element, this is first row, second column element. So first row, second column element, I is 1, j is 2. So you'll have e 2x, e raised to 2x sine 2x. Okay, from this itself we can see it will at least not be these two options, right? But then we never know, it could be this also, so we'll have to solve, right? Because it can be none of these. Now this one is for here you have I2 and J1. So if you put I2 and J1, it is E2 into 2x, that is 4x sine x. And here I is also 2 and j is also 2, so it's e raised to 4x sine 2x. So let's see which is matching here. First one, yeah, first one is matching. So this is the answer. Let's move. A, B, C, and D are given, then which of these sums are defined? So we know that sum of two matrices can be done, or let's put it this way, sum of two matrices exists only when the matrices being added are of the same order. Now, if you see the order of A is of order 2. I can write it 2 by 2. B is of order 2 by 3, C is of order 2 by 1, 2 rows and 1 column, and D is of order 2 by 3, right? So let's see which of the options are true. Which of the options is true? Only B plus D is defined. So B and D have the same order. So B plus D will be defined, but we don't know whether only B plus D will be defined. So let's see the second one. A plus B. A and B are of different order, so A plus B can't be done. B plus C. B and C are again of different order. The number of columns is different. B minus C, again the order is different. So the only option that's true is the first one. Yes, only B plus D is defined. So let's move. The negative of a matrix is obtained by multiplying it by -1, right? If you multiply a matrix by -1, you get negative of that matrix. So the answer would be this. The identity element for matrix multiplication is I. That's the reason why it's called identity matrix, right? Unit matrix. Unit matrix is called the identity matrix because when you multiply any matrix with I, you get the other matrix as it is. And it doesn't matter in which order you multiply. So unit matrix is the answer. A determinant of adjoint of adjoint of adjoint of dot 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 A, where A is a matrix of order n. So here there's a formula, there's a direct formula here. If you have adjoint of adjoint dot 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 A, wherein the order of A is mentioned. So order of A is n, right? Order of A is n, and this adjoint has been taken r times. So adjoint has been written r times. Then the determinant of this is det A raised to n minus 1, and this has to further be raised to r. So if you look at it here, you don't need to do anything further. So you have this, right? So this is done. This is a direct formula, right? Let A be a square matrix and K be a constant. Trace of Ka. So trace of Ka. Actually, it is a direct formula that trace of Ka would be K times trace of A. But still, if we want to solve it, if we are bent upon solving it, we can write it this way: A plus A plus A, K times, right? And then we know that trace of sum of a set of matrices is the same as sum of the traces of individual matrices. So this will become trace A plus trace A plus trace A dot 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 K times, right? This is K trace A. But like I said, this is a direct formula. You should be remembering that trace of K is K times trace of A. However, if you don't know this, then we can get the answer this way, right? Now moving on to the next one. Trace of A plus minus B is trace A plus minus trace B. Again, it's a direct formula. An upper triangular matrix is, so any upper triangular matrix is always a square matrix. Like let's take a matrix. So let's say upper triangular, meaning the elements below the principal diagonal are going to be 0. So if you have something like this, right? This is an upper triangular matrix. So is it a square matrix? Yes, an upper triangular matrix is a square matrix. Upper triangular matrix may not necessarily be a diagonal matrix, because diagonal matrix is a matrix whose non-diagonal elements are 0, but that's not necessary. See, this is a diagonal, but the non-diagonal elements, all the non-diagonal elements are not 0. Like you have 2 here, you have 1 here. So these are non-diagonal elements, so it's not 0. So this is not a diagonal matrix. Scalar matrix, it's not a diagonal matrix, so it can't be a scalar matrix, because scalar matrix is a type of diagonal matrix, right? It's a matrix, it's a diagonal matrix where diagonal elements are equal. Vector matrix is nothing like vector matrix, so the answer is option A. Determinant of this, now we have discussed that if you have any determinant, and if you're finding determinant of any diagonal matrix, this is a diagonal matrix, right? Because you have only non-zero diagonal elements, and non-diagonal elements are 0. So there's a direct formula for finding determinant of diagonal matrices. You just multiply the diagonal elements. So the answer will be ABC, right? ABC. Let A be a matrix and let A inverse be the inverse of matrix A. Then A into A inverse. So inverse of anything in mathematics, not just matrix, is something which when you multiply with the original thing, you get the identity for that operation. So A into A inverse has to be the identity for matrix multiplication, which is the unit matrix, right? So it has to be option C. On the set of matrices, the relation of equality of matrices is. So there are four options given. So let's analyze this. Now let's say I have any matrix A. Will it be equal to itself? Yeah. Any matrix is equal to itself. So yes, it is reflexive. This is reflexive because A comma A will lie in R, whatever the relation is, right? Now, let's say there is a matrix that's equal to some other matrix. Matrix A is equal to B. Then will B be equal to A? If A is equal to B, that's the same as saying B is equal to A. So both mean the same thing. So it's going to be symmetric also. Yes, it is symmetric. Now, transitive, let's talk about, because there's an option here regarding equivalence and there's an option here also, not transitive. So let's see whether it's transitive or not. Now, if A is equal to B and B is equal to C, then will A be equal to C? Basically, when you say matrix A is equal to matrix B, it means that matrix A and matrix B are identical. And when you say matrix B is equal to matrix C, again it means matrix B and matrix C are identical. So if A is identical to B and B is identical to C, A has to be identical to C, right? And anyway, you know, two things equal to the same thing are equal to each other. So yeah, in this case, A will also be equal to C, so it is transitive. So it is transitive also, which means it has to be an equivalence relation. The inverse of the matrix 4, 1, 2, 3 is. So let's write down the matrix. Sorry. So the matrix A is 4, 1, 2, 3. Now we have studied that inverse of matrix A is adjoint of A by determinant of A. Determinant of A can be found as 4 into 3 minus 2 into 1, right? So that is 10. Okay. How do you find adjoint of an order 2 matrix? There's a short method for doing that, right? We just interchange the places of the principal diagonal elements and reverse the sign of the remaining elements. And this, if divided by 10, you get the inverse. So you can see there's no such option here. The closest that you have is this, but then this has to be divided by 10, right? You have to divide it by determinant of A. A inverse will be 1 by 10 into, sorry, A inverse will be 1 by 10 into this matrix. 1 by 10 into adjoint of A, and adjoint of A is 3 minus 1 minus 2, 4. You can see there's no option matching, right? So none of these. Inverse of the matrix 2 minus 1 minus 2, 1. Now, as we know, inverse of any matrix is adjoint of A by determinant of A. Let's try to find the determinant of this matrix. Let me call it A, right? If I find det A, it is 2 minus 2 into minus 1, which is again 2, so this becomes 0. So this matrix is singular, right? If it's a singular matrix, its inverse will not exist, right? It's a singular matrix, so its inverse doesn't exist. The trace of the matrix, this matrix, so trace is just sum of diagonal elements. So trace of A would be, let me call it A. Trace of A would be 1 plus 7 plus 9. This is 17, right? Determinant of this, so let's say this matrix is 1, 6, 2, 20, and I have to find det A. So it would be 1 into 20, that is 20, minus 2 into 6, 20 minus 12, 8, right? So it's 1 into 20 minus 2 into 6, so that is 8. Determinant of this matrix, so we have to find this. This is an upper triangular matrix. Now even for an upper triangular matrix, when we find determinant, we can just do the product of diagonal elements. That itself will be the determinant, right? That's the shortcut. So we can just do 1 into 6 into 4, and that would be the answer, 24. If A is 2764 and let alpha beta belong to R such that alpha A square plus beta A is 102I, where I is the identity matrix, then what is minus of alpha plus beta? So again, this is an order 2 matrix. So we know that the characteristic equation for an order 2 matrix is x square minus trace of A into A plus det A I equals null matrix, right? And this would be satisfied by matrix A. So we have A square minus trace of A into A plus det A I equals O. And A square, so trace of A we can find. Trace of A is 6, right? Trace of A is just the sum of diagonal elements, so it's 6. And det A is 2 into 4 minus 6 into 7, so that is 8 minus 42, that is minus 34. So we have A square minus trace of A is 6, so minus 6A, okay, plus det A is minus 34, so minus 34I is O. If I take this minus 34I there, I get A square minus 6A is equal to 34I. Now if you look at the question here, you have 102I. You get 102I when you multiply 34 by 3. So if we multiply this entire equation by 3, we get 3A square minus 18A is equal to 102I. If you just compare, you will get alpha is 3 and beta is minus 18. So alpha plus beta is minus 15. So minus of alpha plus beta is 15. They have asked you minus of alpha plus beta. So minus of alpha plus beta is 15. So we can move on. If A is minus 7, 5, minus 10, 7, then trace of 7 A raised to 3000 is. So we have to find trace of 7 A raised to 3000. That would be same as 7 times trace of A raised to 3000, because trace of Ka is K times trace of A. Let us first attempt to find A to the power 3000. So again, if we notice here, the trace of A is 0. Trace of A is 0. Okay, minus 7 plus 7. And determinant of A is minus 49 plus 50, which is 1. So as per the characteristic equation, again, it is x square minus trace of A x plus det A I is O. So if we put matrix A in this, we get A square and trace of A is 0. So this entire term, second term will be 0. This is 0. And det A is 1. So it's plus 1 into I. So A square plus I is O. That gives us a square is minus I. You could have multiplied a with itself and even then you would have got the same thing. But if you don't want to do that multiplication, you can go this way, right? Now we have, what is a raised to 3000? So a raised to 3000 would be a square raised to 1500. A square is minus I, so that is minus I raised to 1500. That is I raised to 1500, which would be I itself. So a raised to 3000 is I. This is a raised to 3000 basically, right? So the trace of 7 times a raised to 3000 is 7 times trace of a raised to 3000. So 7 times trace of a raised to 3000. 7 times trace of a raised to 3000. Now what is a raised to 3000? A raised to 3000 is I. So it's 7 times trace of I. Trace of I. Now what is trace of I? I is 1001. So trace of I is the sum of diagonal elements, which is 2. So it's 7 times 2, which is 14. So the answer is 14, right? This is the answer. If a plus 3 2b, so this matrix that has a plus 3 2b plus ac minus 1 and 4d minus 6 is equal to 0 minus 7 3 and 2d, then the sum of the roots of the quadratic equation x square plus ax minus b lying in the interval open interval 0 to 2 is. So since these two matrices are equal, we'll be equating the corresponding elements. So a plus 3 has to be equal to 0, which means a is negative 3, right? And we have 2b plus a, c and d are irrelevant because in the equation we just have a and b, so we just need to find a and b. 2b plus a is minus 7, and we have the value of a already, so sorry, 2b minus 3 is minus 7. This gives us b is minus 2. B is minus 2. Now when you plug in the values in this equation, you get x square plus ax means minus 3x minus b is plus 2 equals 0. If you solve this quadratic, you will get two roots, x is equal to 1, x is equal to 2. Now here we need to be careful. They have asked you open interval 0 to 2. So 2 is not included, right? So there's only one root which lies in this interval, and that is x is equal to 1. So they have asked you sum of roots of the quadratic equation so and so lying in this interval. So since there's only one root, there's no question of sum. The answer will be 1, right? So the answer is 1. If det A is 4 and det B is 3, what is det AB? So we know that determinant of product of two matrices is equal to product of their determinants. So this would be 4 times 3, which gives us 12, right? Okay, let A be this matrix and B is this matrix and C is this, such that C is alpha A plus beta B, then alpha plus beta is. So basically the question is asking you, is there any number, there may be some number alpha which we can multiply to A and some number beta which we can multiply to B, such that if we add alpha A plus beta A, we get C. So what would be the sum of those two numbers? That is, what is the sum of alpha plus beta? So let's do it. So alpha A, basically we'll be multiplying every number here to alpha. So we'll get alpha, 2 alpha, 3 alpha, 0 into alpha is 0, 1 into alpha is alpha, 0 into alpha is 0. And beta B is minus beta, right? 4 beta, 3 beta, beta, and 0, 0. Alpha A plus beta B is C. So if I add the first row, first column element of both the matrices, okay, this one and this one, I get alpha minus beta, and that should be equal to the first row, first column element of C, which is minus 1. So that gives me beta minus alpha is 1. Okay. And if I add the second row first column element of both matrices, I get beta, right? 0 plus beta is beta, and that should be equal to second row first column element of C. So that means beta is 3. We have obtained the value of beta. Now we plug in that here. We will get alpha. From here we get alpha is beta minus 1. Okay, from this equation. And beta is 3. So 3 minus 1, which is 2. So we have obtained both alpha and beta. So alpha plus beta would be 2 plus 3, which is 5. If det A is 2 and A is of order 3, then determinant of adjoint of adjoint of adjoint of A is. So like we had discussed in one earlier question, determinant of adjoint of adjoint of adjoint, if say this is repeated r times and then you have A, this would be det A raised to n minus 1 whole raised to r, right? Where n is the order of A. So n is the order of A. Here is given that A is of order 3, so n is 3. So the answer would be det A raised to n is 3, so 3 minus 1 is 2, and 2 again has to be raised to r. So here the number of times adjoint has been written is r, which is in this case 3. Adjoint has been written 3 times. Keep in mind it is not det A square whole raised to 3, so you will not multiply these powers. It is det A raised to 2 raised to 3, right? So this would be det A raised to, so first you have to raise 2 to 3 and then you raise det A to that. So this is 2 cube, which is 8. It would not be this. Please keep in mind it would not be this, right? You will not be multiplying the powers here, right? This is wrong. Fine, so it would be det A raised to 8 and det A is 2 here. So this is 2 raised to 8, which is 256. If det A is 3, det A raised to 4 is, so we know that det A raised to, determinant of A raised to n is det A 4 raised to n. So in this case, det A has been given as 3 and n is 4, so it's 3 raised to 4, 81, right? I hope we have not left out any question. Just let me check. Okay. So I think we have discussed all the questions. So hope you have understood everything. Thank you.